Have you ever wondered where everything came from? The galaxies, the stars, the planets, you and me? What if I told you that everything, every atom in your body, was once part of a massive cosmic explosion, a single moment that gave birth to all of existence? This is the story of the universe, from the moment of creation to the mysteries of its ultimate fate. Stay with me as we unravel 13.8 billion years of cosmic evolution in just a few minutes. And if you're fascinated by the mysteries of time, space, and existence itself, be sure to subscribe to Truth in Time, where science meets philosophy and history comes alive. Before time, before space, there was what? Was there a void? A quantum vacuum? A realm beyond our comprehension? The laws of physics break down when we go back to the very first moment. Some scientists believe the universe emerged from a quantum fluctuation, an unpredictable event where energy momentarily flickers in and out of existence. But if this is true, what triggered the fluctuation? Could the answer lie in the multiverse theory, where infinite universes are constantly forming and collapsing? Or perhaps the ancients were onto something when they spoke of creation emerging from chaos, a cosmic rebirth from an eternal cycle of existence. Could our universe be one of many? A ripple in a vast ocean of realities? Then, in an instant, it happened. A singularity, an infinitely small, infinitely dense point, erupted in an event known as the Big Bang. In that moment, time and space were born. It was not an explosion in space, it was an explosion of space itself. Imagine a balloon inflating, but instead of air, it's the very fabric of reality stretching outward. In less than a trillionth of a second, the universe expanded from smaller than an atom to billions of light years across. This event, called cosmic inflation, was unimaginably fast, faster than the speed of light. The energy unleashed in this moment would later become the matter and energy that make up everything in existence. As inflation slowed, the universe was a seething, blinding plasma, a chaotic, high-energy soup of particles. Matter and antimatter collided and annihilated each other. But, in a strange twist of fate, a tiny imbalance allowed more matter to survive than antimatter. Had this imbalance not occurred, the universe as we know it wouldn't exist. This was the first step toward everything. The stars, the galaxies, and life itself. At this point, the universe was still too hot for atoms to form. The first few minutes saw the birth of atomic nuclei, mostly hydrogen and helium. But free electrons scattered light, making the universe a dense, impenetrable fog. Then, 380,000 years after the Big Bang, something miraculous happened. The universe had cooled enough for electrons to combine with atomic nuclei, forming stable atoms. For the first time, light could travel freely. This moment, called recombination, allowed photons to escape, and that light still exists today as the cosmic microwave background. If you tune an old TV to a static channel, part of that noise is the ancient echo of the Big Bang. A whisper from the dawn of time. The universe was now vast, cold, and dark. But not for long. For millions of years, darkness reigned. But gravity was at work, pulling together clouds of hydrogen gas. Then, 200 million years after the Big Bang, the first stars ignited. These stars were unlike anything we see today. Massive, burning at millions of degrees, living fast and dying young in spectacular supernovae. Their violent deaths scattered heavier elements, carbon, oxygen, iron, the very ingredients needed for planets and life. Slowly, these stars grouped into the first galaxies. Their intense radiation began a new era, reionization. The universe was finally transparent to light, revealing the grand cosmic structures that would shape the cosmos. For billions of years, gravity shaped the universe, pulling galaxies into clusters, forming intricate cosmic webs. For a long time, scientists, thought this expansion would slow down. But then, in 1998, something changed. Astronomers discovered that the universe wasn't just expanding, it was accelerating. Something unseen, something mysterious, is pushing galaxies apart faster and faster. They call it dark energy, and it makes up nearly 70% of the universe. But what is it? Some believe it's an unknown force woven into the structure of space itself. Others suggest it's a hidden interaction between dimensions, or even a sign that our universe is just a holographic projection from a deeper reality. One thing is certain, we barely understand it. What happens next? Will dark energy keep stretching space until galaxies drift apart, stars burn out, and the universe freezes in a lonely void, an event called the Big Freeze? Or could gravity eventually win, reversing expansion, pulling everything back together into a final cataclysmic collapse? The Big Crunch. Some theories even suggest a cosmic rebirth, the universe contracting and then exploding into a new Big Bang, a never-ending cycle of death and renewal. And then there's the wildest possibility of all. What if reality itself is a simulation, a construct beyond time, where our universe is just one in an endless chain of simulations, looping through infinite variations? If so, what happens when the simulation ends? Perhaps the greatest mystery is that we are here, conscious beings capable of asking these questions. We are the universe contemplating itself. We are not just observers of this cosmic journey. We are part of it. Our atoms were forged in the hearts of dying stars, our fate tied to the vast, ever-expanding tapestry of space and time. And so, the story of the universe continues. But what happens next is still unwritten. If you want to keep unraveling the greatest mysteries of existence, be sure to subscribe to Truth in Time. Let's explore the past, present, and future together.